Okay, question 9. So we've two boats, A and B. They're both traveling north. They are 50 meters apart in the horizontal direction. And theta here is this angle, well, the angle between the two. Part A, show that y equals x plus 50 cot theta. Okay, so it's only worth 1 mark. It shouldn't be that difficult, but it's not simple. This is the last question in section A of the paper, guys, so you know it's going to be hard. Okay, so I'm drawing a triangle here. Once you see this, once you see there's a trig relationship, try to think SOHCAHTOA, especially if it's only 1 mark. So this is 50. Y is the total distance from here to B. So this distance here is y minus x, because look, that's x, like that's x, and the total's y, so this obviously has to be y minus x. This angle's theta, so this angle's theta, because these are alternate angles. So for part A, we can say the tan of theta is equal to opposite 50 over adjacent y minus x. Cross multiply, y minus x equals 50 over tan theta. 50 over tan theta is 50 cot theta, by the way, guys. And if I add x to both sides, we get x plus 50 cot theta. So that's what cot theta is. It's 1 over tan theta. Okay, so that's shown fairly well. That's the easy part of the question. Part B. Arguably, it was worth more than 1 mark, but anyway. So part B. At time t, the following conditions are true. Boat B has traveled 10 meters further than boat A. Boat B is traveling at double the speed of boat A, and the rate of change of the angle theta is minus 0.1 radians per second. Okay, so the speed of boat A is dx dt, because x is the distance he's traveled, so dx dt is the speed of boat A. dy dt is the speed of boat B. Okay, so we have y is equal to x plus 50 cot theta. Now we're trying to find dx dt, but if I find dy dt here, which I'm going to do, dy dt is equal to dx dt. I'm going to get naturally my dx dt here, because the derivative of x with respect to t is dx dt, because this is a function of t. The derivative of 50 cot theta with respect to t, well, you have to use chain rule because theta is a function of t. So this becomes the derivative of cot, by the way, guys, is minus, it is, well, hang on, I better put it like this. So it is minus 50 sec squared. No, sorry, it's cosec. This is, you can find this in the formula booklet, guys. Cosec squared theta. So the derivative of cot is minus cosec squared. So that's why I have it there, and then 50 here. But you have to multiply this by the derivative of theta, because as I said, theta is a function of time. It is changing. Okay, so that's the first step. Now we know that at this time t, boat B is traveling at double the speed of A. So I can actually say, well, let's write it up here, dy dt is equal to 2 times dx dt. So that's because, well, the speed of this speed is twice this speed, so to make them equal, I double that. So instead of dy dt now, I can put in 2 times dx dt. I'm doing this because I'm trying to find dx dt. The speed of boat A is dx dt. So this is equal to dx dt minus 50 cosec squared theta times d theta dt. Subtract dx dt from both sides. 2 dx dt minus 1 dx dt is 1 dx dt equals minus 50 cosec squared theta times d theta dt. Now, this is what we're trying to find, but, well, we do, at time t, we do know d theta dt, it's minus 0.1. What we don't know is cosec squared theta. We don't know what theta is. But there's one bit of information we haven't used yet, and it's this. At time d, t, boat B has traveled 10 meters further than boat A. So that means that this distance here, the y minus x, that's that's how much further boat B has traveled, this is 10. So I can find the theta now, because theta is going to be, well, it's the arctan of 50 over 10. Tan of theta is 50 over 10. So over here, I'm going to write at time t, tan theta equals 5, 50 over 10, which is 5. Therefore, theta is equal to, I'm going to get out my calculator, theta is equal to arctan of 5, which is this, but I want the, I think I'll take the decimal version, please. Convert to decimal. 1.3734. 1.3734. So dx dt, which is the speed, is equal to minus 50 times cosec, 50 times cosec squared of 1.3734 times minus 0.1, because they give us this, like, the rate of change of the angle theta. So the rate of change of the angle theta is d theta dt. So that, this is my speed, and now I can just put that, all of that, straight into my calculator. Okay, so it's just minus, no, don't want that, minus 50 times cosec, so cosec is here, cosec of 1.3734. It's squared, guys, so be very careful putting a bracket here. This bit is squared, so that's how you write cosec squared, and then times negative 0.1, close bracket, press enter, and I get exactly 5.2. And that's it.